look at a question. Before the question again, sorry for the noise. It's daytime now, it's daybreak, so the noise is going to keep coming. All right, and I have to continue, so just pardon me. There is going to be noise here and there. All right, so let's look. A ladder leans against a school building at a point P from the same horizontal ground. The angle of elevation from the foot of the ladder to P is 60 degrees, and the distance from the foot of the ladder to the base of the building is 3 meters. Take cos 60 degrees equals 1/2, and tan 60 degrees equals √3. Like I said, you see, the angles have been given. Cos 60, you need calculator, but because you know it's calculator, they have given it to you. Cos 60 degrees is 1/2. Tan 60 degrees is √3, right? So it says A, illustrate the information in a diagram. B, find the length of the ladder, and then find the height of the building at point P. Then you ask yourself, this thing doesn't look like any of these things that we have been explaining so far. Yes, it looks like that. So in the next slide or next few slides, you are going to see that it is. So when you get a question like this, you have to look for which one is a 3 representing and the 60 degrees. Now we have, before we look at it, we have angle of elevation and angle of depression. Elevation means the angle above your eye, so raising your eye to see something upwards. And then depression means looking down, so it means the object is below your eye. Okay, so if I should draw my right angle triangle, right, so over here this becomes my angle of so my eye is here and then the angle is here, so the angle here becomes my angle of elevation, so because I am looking up. You get it? I am looking up. Let's see, you will see why that part is angle of elevation. We will look at the difference between angle of elevation and angle of depression later in another video. So let me clear. All right. Okay, so let's look at something. A ladder leans against a school building. We all know that when you put a ladder against a wall, or a ladder against a building, a ladder against a tree, anything you put a ladder against is going to form a right angle triangle. Yes, let's see. It's going to form a right angle triangle. Look at this. So we have a ladder against a building here, and then we have a ladder against a wall. I decided to keep the names on the images and then the website on the images so that I will acknowledge where I picked it from. Okay, so a ladder leans against a building. Now look, it's leaning against a building. Look at something here. So from here to here, okay, this is the building, is that not it? And then this is the foot of the ladder to the foot of the wall, right? And then this is the ladder itself. That becomes our hypotenuse. Can you see that? So our hypotenuse here, our base here, and then our height here. Can you see that? Good. Let's look at the other one too. A ladder leaning against a wall. So let's say this is the school building. Okay. In this diagram, let's say it's a school building, the wall of the school building. Okay. Now we can see the ladder because of how the ladder is turning. The ladder becomes our hypotenuse. You get it? Then this is the base of the ladder. Okay, from the foot of the ladder to the foot of the wall is the base. Have that in mind. The foot of the ladder, and then the foot of the wall, that is the base. And then we have the height. You see, the height. That is from the foot of the wall to the top of the ladder, or to the top of the wall where the ladder is found. From the foot of the wall to the top of the wall where the ladder ends, or to the end of the ladder. That is the height. So can you see that? And then that will form an angle of 90 degrees here, 90 degrees here. So that is a right angled triangle. Okay, now A says we should illustrate it on a diagram, so that's what we are going to draw. And then B says we should find the length of the ladder. So you are going to find the length of the ladder this side. That means you are finding hypotenuse. Simple. And then the II says you find the height of the building at point P. Where is point P? A ladder leans against a school building at a point P. A ladder leans against a school building at point P. So where do you think is the P is going to be? Is going to be here. So the P, because the ladder leans against the building at that point. You see at the foot here, over here, the ladder is not touching the wall, right? Over here, the ladder is not touching the wall. But at the top over there, the ladder is touching the wall. So it leans against the building at point P. So the top is going to be P from the same horizontal ground. So from the ground to the top. So that is the P. The angle of elevation from the foot of the ladder to P is 60 degrees. I said angle of elevation means the angle that the observer sees when we look upwards. Okay, so now we are saying the point is P, right? So let me now use one of the diagrams, only one of the diagrams. Okay, so let me use this one. Okay, and then this is our P. So the angle of elevation from the foot of the ladder to P is 60 degrees. So this is going to be the angle because we are going to look upwards so we can see P. Angle of elevation from the foot. Where is the foot of the ladder? There's the foot of the ladder. Is that not at the end of the ladder? Angle of elevation from the foot of the ladder to P. So we are looking at it from the foot of the ladder to P. So this is where the angle is found. And mind you, the angle could be found only up here or down here. The 90 degrees is constant. So if you should be here, over here is not the foot of the ladder, right? But from the foot to P. So the elevation is this side. The angle of elevation is this side. And the question is saying that is 60 degrees. And the distance from the foot of the ladder to the base of the building is 3 meters. The distance from the foot of the ladder to the base of the building is 3 meters. So let's see the distance from the foot of the ladder. Now, where is the foot of the ladder? Look, we've said that the foot of the ladder is here, right? And where is the base of the ladder? The foot of the ladder and then the base of the building. Where is the base of the building? The side is base down. This is the base of the building and this is the foot of the ladder. So the distance between them is what? 3. That means our base is 3. So that being said, let's look at the next. So same thing. Now a bit more of a diagram. So we have the wall here, we have the base here, and then we have the ladder. Okay, so this is the ladder leaning against hypotenuse. Then from the base of the building to the foot of the wall, that is our base. Okay, same applies here. So this is, now you can see they look the same. Okay, this and that look the same. And then, so that is our A. So our A, oh, I turned my 60 degrees. The angle, please, is 60. Okay, so the angle is 60. I think I've turned it. I don't know how come I turned the angle. It says, so this is the A. The A is saying we should illustrate the information in a diagram. So draw a right angle triangle. Then please show the point P. The question asked. Then it said, so this one is our wall, right? This is the school building. This is our ladder. And then the foot of the building or the base of the building to the base of the ladder or the foot of the ladder is our 3 meters. So our base is 3. Our hypotenuse has not been given. Our height has not been given. But we have been given the angle. Are we there? And that's very simple. Okay, great. So that is our A. Now we look at B. B, I says you find the length of the ladder. Length of the ladder. Now if you remember the trigonometric ratios, we said we are always given two sides, either adjacent and hypotenuse, or so that is either opposite and then hypotenuse, or adjacent and hypotenuse, or opposite and hypotenuse. But sometimes the angle will be given. So you see that one, we are using it to find the angle. Sometimes the angle will be given, then the two sides to one will be given. So it becomes very simple. The same thing. Now let's see, we know our hypotenuse. Let's indicate them. Where is our opposite? Yes, there's the opposite. And then obviously there's our adjacent. All right. So our opposite has not been given. Our hypotenuse has not been given, but our adjacent has been given. So which ones? We have been given adjacent. So ka twa. We are looking for the one that has adjacent. So which ones are those? Twa has adjacent and cos also has adjacent. Can you see it? Good. So are we going to use tan or cos? Tan or cos? Anyone will work. Any of them. That is why, look here. It says take cos 60 to be 1/2. So if you are using the cos theta, then you are going to use that one. And tan theta to be √3. So if I are going to use tan 2, that is it. Okay. But unfortunately, this very one, the tan will not work. Okay. Although we have opposite and adjacent, the tan will not work. But then the cos, adjacent, and then hypotenuse will work. Why am I saying the twa will not work, but the cos will work? The ka, will work. Because the question said we should find, now let me clear my board. The question said we should find, we are looking for I, right? Length of the ladder. This is it. Is that not it? Length of the ladder. And we said the length of the ladder is what? Is h. So now we are saying ka will work and twa will work. We know that the adjacent has been given. Is that not it? This one has adjacent. This also has adjacent. But which of the two will work? Any of them should work. But then which one will answer our question? Okay. Any of them will work. But I'm saying over here, twa will not work because you are looking for the one that answers our question. You are looking for the length of the ladder. Where is the ladder? This one. So which one do you think you are going to use? The ladder has what? The h. So you are going to use adjacent and then hypotenuse. The question gave us adjacent. We are going to use hypotenuse because that is the one we are finding. Are we there? Good. Now, the question, the II says we should find the height of the building. Okay, so with the II, then which one are we going to use? So with the II, that is where we can use our twa, because II will mean that we are looking for this side. Okay, so that one we use the twa. You get it? So finding the I, we use the ka because we should know our A and our H. But then finding the height of the building, this is the height of the building, right? Then we use our twa because we need O and A. I hope you get why I said with the I, the twa will not work, but then the cos will work. Great. So now let's move on. This video has been very long, but sorry, excuse me for that. So we continue. So length of the ladder, I'm saying that let the length of the ladder be PR. Length of the ladder, because if this is P, so I'm saying P, I'm deciding to, so P here, Q, and R. So the question didn't tell me to use Q and R, that's why I'm saying let the length of the ladder be PR. So cos theta. Now the theta I said is the angle. The question gave us the angle, which is 60. So cos 60 degrees is equal to, so we are using car, right? Adjacent over hypotenuse. Where is our adjacent? So our opposite is here. Our hypotenuse is here. So our adjacent is here. So 3 meters. That is why I have 3 meters over PR, which is this one. So over PR. Now I've used R here, so let me write it there. Okay, so cos 60 degrees is equal to 3 meters over PR. 3 meters over PR, over line PR. So what is cos theta again? The question gave us right here. Take cos 60 degrees. I'm using cos theta instead of 60, sorry. Cos 60 degrees is what? 1 over 2. So where we see cos 60 degrees, you put 1 over 2. Cos 60 degrees should be 1 over 2. So we have 1 over 2 is equal to 3m over PR. You see, so cos 60 degrees is what? 1 over 2. So it's going to be 1 over 2 is equal to 3m over PR. Now, how do we do it? We cross multiply, remember. So the 3m will multiply the 2, and then the 1 will multiply the PR. So we cross multiply. So we have 3m times 2, and then 1 times PR. Okay, you remember this. So 3 times 2 is 6, so 6m. PR is equal to 6m. Therefore, our PR. So the question, we should find the length of the ladder. So therefore, the length of the ladder is what? 6 meters. That is the I. The I says you should find the height of the building. Now look, we now know this side to be 6. So we can easily find this either using Pythagoras' theorem or using the trig ratios. So we are going to use both of them. All right. So let's begin. The BII, so we are now using the trig ratios. Tan, you remember I said we are looking for the height of the building. So we need TOA. Why TOA? Because we have our adjacent and then we are looking for the opposite. So we continue. So I said let the height of the building be PQ. So I've already said that I'm using Q and R here. All right. So I've put a 6 here because I've already solved that. Okay. So if you are finding this one, then we are using TOA. So tan 60 degrees, I've said that theta is the angle. So the angle has been given 60. So tan 60 degrees is equal to opposite over adjacent. And our opposite is what? Let's see. Our opposite, we don't know. And that's what we are saying, PQ. So PQ over adjacent. Our adjacent is what? 3. But the question has given us tan theta, right? To be root of 3. To be root of 3. So the question has given us tan theta to be root of 3. So where we see tan theta, we put root of 3. So it's going to be root of 3 is equal to line PQ over 3 meters. Root of 3 is equal to line PQ over 3 meters. Are we there? Good. Now what do? We multiply through by 3. Or we cross multiply because we know every whole number is over 1. Do you remember? Sorry, I moved backwards. So every whole number is over 1. I believe you remember that. So trying to put 1 there. Yes, let's imagine there's 1. So we cross multiply. PQ multiply 1, right? Root 3 will multiply 3. So every whole number is over 1. So we just cross multiply through by 3. So in that case, we are going to get 3 meters times root of 3. 3 meters times root of 3. Like I said, we are cross multiplying. And then PQ multiply 1 is the same as PQ. So line PQ is equal to 3 meters times root of 3. 3 times root of 3 is 3 root 3. Why? If you have 2 times x. What does it become? 2x. We remove the times. So 3 times root of 3 becomes 3 root 3. We just remove the times. And then we put the meters at the back. Okay, that is all. That is it. Are we together? Good. Now, the answer is 3 root 3. We can also use another way, like I said, Pythagoras' theorem, because we know two sides. Pythagoras' theorem says that if we know this side and we know this side, we can find this side. Same way, we know this side and we know this side, so we can find this side. How do we do that? So I've already used PQR. So line PQ squared, that's the height squared, plus line QR squared, that's the base squared, should give us line PR squared, which is the hypotenuse squared. But this one has given us hypotenuse, and we are looking for what? The PQ. So what do? We group like terms. So line PQ squared is equal to line PR squared minus, so line PQ squared, that's what we are finding, right? Is equal to line PR squared minus QR squared. Why? Line QR is crossing the equal sign. It's coming to a different country. See, it's moving from here to here. It's positive, has to change to negative. That's just grouping of like terms. Then we put the figures there. So line PQ squared equals 6 squared, because PR squared, where's that PR? Here, 6 squared, minus QR squared, where's that QR? 3, so 3 squared. 6 squared is what? 36. 6 squared means 6 times 6. It's not 6 times 2, it's 6 times 6. 6 times itself 2 times, so 6 times 6. And then 3 squared means 3 times 3, is not 3 times 2. 3 times itself 2 times, so 3 times 3. So 6 squared is 36, 3 squared is 9. 36 minus 9. 36 minus 9, what do we have? 27. Okay, but we have line PQ squared equals 27. We don't need PQ squared. What do we need? We need PQ. So we bring the square root sign at both sides. You remember? Square root sign at both sides. So the square roots will cancel the square here. So we'll be left with only PQ. So PQ is equal to root of 27. Root of 27, there's no perfect square. There's no perfect number. Root of 27 means which number will multiply itself to give us 27. Don't say 3, 9. Which number? One number times itself. So if you imagine it was 25, the answer would have been 5. Why? 5, 5, 25. Imagine it were 16. The answer would be 4. That would be 4, because 4, 4, 16. This is 27. No number will multiply itself to give you 27. So the answer is root 27. But we have to simplify. Okay, you have to simplify. So it's going to be, the answer is going to be 3 roots. So PQ, line PQ equals root of 27, because we've cancelled. So the answer is going to be 3 root 3. 3 root 3. Like we had in the first one. But wait a minute. Why is root 27 3 root 3? Why is root 27 3 root 3? Let's look at that. So now we have our perpendicular height to be 3 root 3. We have our base to be 3 meters. And then 3 root 3 meters. No, don't forget the meters. Our base 3 meters. And then our height equals 6 meters. Now, why is root of 27? Why is root of 27 3 root 3? Let's look at that. Now, under the topic sets, you remember sets. Actually, the correct pronunciation is SATs. SURDS, SAT. But sets, I hope you remember. It's a Form 3 topic. All right. The next lesson, that is lesson 2, is going to be about one of the questions is going to be on set. So, excuse me, we will look at that. Okay. All right. So from sets, we learned that if you have root of 27, you have to find two numbers that when you multiply, you get 27. Two numbers that when you multiply, you get 27. But one of them should be a perfect square number. When we say a perfect square number, it means a number that we can get by multiplying another number by itself. To know the perfect square numbers, I tell my students, just recite 1, 1, 1. So 1 is a perfect square number. 2, 2, 4. 4 is a perfect square number. 3, 3, 9. 9 is a perfect square number. 4, 4, 16. 16 is a perfect square number. So just keep reciting. 1, 1, 1. We have one perfect square number. 2, 2, 4. Perfect square number. 3, 3, 9. Perfect square number. 4, 4, 16. Perfect square number. 5, 5, 25. 25. Perfect square number. 6, 6, 36. 36. Perfect square number. 7, 7, 49. 49. Perfect square number. 8, 8, 64. Perfect square number. 9, 9, 81. 81 is a perfect square number. 10, 10, 100. 11, 11, 121. 12, 12, 144. 13, 13, 169. So try and learn all those ones. So which two numbers will multiply to give us 27? We have 9 and 3. 3 times 9 is 27, right? Good. So 1 should be a perfect square number. Yes. 9 is a perfect square number. Don't forget, when I was reciting, I said 3, 3, 9. So 9 is a perfect square number. You get it? So now, so it becomes root of 9 times 3. I advise that you bring the perfect square number first. Okay. So the perfect square number first. Perfect square number. So root of 27 is the same as root of 9 times 3. Are we there? And then root of 9 times 3 is the same as root of 9 times root of 3. So let me clear my board and continue. It's the same as root of 9, root of, let me use red, sorry. The same as root of 9 times root of 3. You see, the first one, the root was for everything, right? Now I've separated them. So now what do? We have seen that the 9 is a perfect square number. So we ask ourselves, which number will multiply itself to give us root of 9? Which number will multiply itself to give us root of 9? Sorry, which number will multiply itself to give us 9? Root of 9 means which number will multiply itself to give us 9. Root of 9 means which number will multiply itself to give us 9. Again, when you see root of a number, which number will multiply itself to give you the number under the root sign. So like I was reciting. So now let's recite 1, 1, 1. 2, 2, 4. 3, 3, 9. So which number multiplies itself to give us 9? 3. 3, 3, 9. So root of 9 is the same as 3. So we have 3 times root 3. And like I said, if you have 2 times x, what do? You remove the times and then you make it 2x. It's the same thing. We have 3 times root of 3. So remove the times and it becomes 3 roots 3. That is why root 27 is 3 root 3. So that is why it is 3 root 3 meters. All right. Good. So the next one, we are going to look at magic square, which is going